Hi, my name is Bridget Kager. I'm a junior at the University of New Hampshire, and here will be my breakthrough video for the 2022 summer internship, where we'll be learning about science and we'll be doing writing our own hypotheses statement. So with me, I have three students, Maureen, Brendan, and Anthony. They could join us on camera. Okay, so I'm going to share my screen. We're going to do this and share my screen. So first, we're going to be discussing solar and lunar eclipses as a general. All right. So obviously, we have a solar eclipse is a phenomenon that occurs when the moon's orbit falls between the Earth and the sun. Because of this, a shadow is cast over the Earth. This process can only take place during a new moon. We have the different types of solar eclipse: a total, partial, and annular, which is some side work we don't really know. Now the shadow, the umbra, the dark center of the moon shadow. The shadow gets smaller as it reaches Earth, and people beneath it observe a total solar eclipse. Next, we have the shadows of the solar eclipse. This is going to be a little bit more important for our hypotheses. So a solar eclipse happens every 18 months. However, because its effects on certain area and are even less often than that, and many come to watch. It's a little bit more. A lot of people come to watch, and you need eye protection to be worn during the eclipse. So it happens every 18 months. Then we have a lunar eclipse, which takes place when Earth blocks sunlight from reaching the moon. As a result, Earth casts a shadow onto the moon, and the moon can look a reddish-orange color. That's another. The Earth orbits the sun, and the moon orbits Earth. Some Earth falls in front of the sun and in between the moon's path. And then we have the types of lunar. So it'll go through total and a partial. And unlike solar eclipses, which last only a few hours, lunar eclipse lasts for several hours. Next, we're going to be going into formulating a hypothesis. So when we're formulating a hypothesis, there's some questions we want to be able to answer. So after this lesson, hopefully we'll be able to answer this. Is your hypothesis based on your research on a topic? Can your hypothesis be tested? Can actually be tested? And does your hypothesis include independent and dependent variables? Now, hypothesis, when you're writing, it's a prediction, but it involves much more than a direct guess. It's really a statement using if, then, because. Most of the time, it begins with a question, which is then explored through background research. So we have our background research, and we're going to be looking at a solar eclipse for our hypotheses. So we know it happens between every 18 months, and we're going to try and work on a statement between that. So the question I think we're really going to be working on that you guys can write down is, how do you predict a solar eclipse? You guys can take about 15 to 20 seconds just to write down a few bullets of how do you predict a solar eclipse? Now, when writing a hypothesis, of course, we use if, then, because it's a great way to really build a statement when you're writing it. It's very needed in experiment, and when you're doing a lab report, it's always good. It's what you'll be testing, the big question, what you'll be testing. So from that, what are some of the ideas that you got, some of the bullets you wrote down from our question of how do you predict a solar eclipse? Maureen, like to share?
Okay, so I noticed from the slides that we emphasize that a solar eclipse occurs every 18 months. So I'm thinking that that might be the opening to my if, then, because for that hypothesis. So I don't know how to perfectly formulate it, but I think I would begin with, like, if a solar eclipse occurs every 18 months,
Nice.
then we can predict when a solar eclipse will occur. And then I'm still working on the because part, but I think if it is known if we know and we're able to track the regular orbit of the moon around the Earth and the regular orbit of the Earth around the sun, that should answer how we can track when a solar eclipse would occur.
Right, that's great. Now, Anthony and Brendan, we're gonna try and formulate this full statement. So let's start with the if. So what are we using as if? If we can track irregular orbit or irregular orbit, that would probably be the start of it. So if we can track the regular orbit of the moon around the Earth, and then of the Earth around the sun, then we have to come up with our then. Does anyone have any ideas about maybe our then? We said if, we're in our if phase. So if this happens, then what will happen next? What are we thinking? If anyone has any ideas. So then what? What are we able to see? Are we able to predict something? Are we able to see something?
So my hypothesis, I think, might be able to help the two other students, because I think they can sort of piggyback off of what I'm saying as sort of a reverse. So
Yeah.
again, I'm just going to repeat my hypothesis,
Yeah.
maybe for the benefit of the group. So you can correct me if I'm using the formula wrong, but my statement reads, if a solar eclipse occurs every 18 months, then we can track when a solar eclipse will occur because of the regular orbit of the moon around the Earth and the regular orbit of the Earth around the sun.
That's fantastic. That's a great hypothesis, because you use if, then, because, and you can also switch it too. If we can track the regular orbit, then we are able to predict when a certain time, because we know it occurs every 18 months. It seems you really guys have hypotheses down and you really know the format of it. Thank you guys so much. And I'm so glad we had this little lesson on solar eclipse and forming a hypothesis. And I hope you take it to your lab reports and really make sure you have that statement down, the 3 most important things. Thank you so much.
Thank you.
Thank you.
Thank you. I'm gonna raise my hand.
Okay, so I see that I think we have a couple of questions and I just want to make sure everyone gets it all cleared up. Brendan, you're first.
So for the format of the hypothesis, can I change the then and because part?
Yes, you can. You can do that because as long as, again, you're using the right terms, you're using in the right context, you can. As long as you're really explaining your statement and your side of it. Again, what you want to show to be tested. So it's saying, because I saw this, if this did occur, then my hypothesis would show. Kind of obviously moving around the language a little bit, but still getting to your point. So that's a really good question.
Mhm.
And then see if there's any more before we end our session. There's many ways to create hypotheses too. There's obviously observational studies, pervasive studies, and many different observational. You're collecting data more first, and then you're kind of writing your hypotheses. But with this, we saw our evidence and then we created it. So if there's any more questions, I think that's a question hand. There we go.
So if we know the regular orbit of the moon around the sun and the regular orbit of the Earth around the moon, then we can track over the solar eclipse will change because they occur every month. And to back that up, we can do a reversal.
Right, so you can turn it around, right, the hypothesis the other way, because you're still using the necessary terms in order to, again, raise your point, raise your question, see what's being tested, while still formulating your own hypothesis. So that was a really good question. Well, thank you guys so much. I think we got a lot out of this. I think you guys really know how to build a hypothesis statement and really work on observational studies and just looking at PowerPoints and kind of gathering all that information, putting it together. I hope you guys have a great night and thank you so much.
Thank you.
Thank you.
Thank you.